All right, we're going to look at this definition here. It's the angles formed by a non-zero vector and the coordinates axes are called direction angles. For the vectors and the cosines of these angles are direction cosines. So what we're going to be doing is using the unit vectors and our formula for cosines. So down below where you see this v, so we'll have a vector u. For the v, we're going to use the unit vectors. So we'll use I, which is 1, 1, 1, 0, 0, j, which is 0, 1, 0, and so forth. All right, so let's take a look at this problem here. We want to find the direction cosines and then the direction angles. We'll just do them all in one. So here we're using alpha, beta, and gamma. So note that I is 1, 0, 0. And K. So we're going to formulate this U with each one of these to get the three answers. So cosine alpha, so we'll let alpha equal UI. So cosine of alpha is equal to U dot I over the magnitude of U multiplied by the magnitude of I. So the dot product will give us 2 times 1 plus 2 times 0 plus 1 times 0 using U and I. The magnitude of U, square root of 2 squared plus 2 squared plus 1 squared. And the magnitude of each of these others is just going to be 1, but for I specifically, it's going to be 1 squared plus 0 squared plus 0 squared. The others will amount to 1. So cosine of alpha will equal 2 over root 9, it looks like, times 1. So that equals 2/3. So to solve for alpha, that's inverse cosine of 2/3. And they want it in degrees, so we'll grab our calculator. I believe this is already set for degrees. It is. So we need a second function cosine and 2 divided by 3. 48.19 degrees. We'll take a look if there's anything that we need there. So alpha. See if they want us to round. Nearest integer, so just 48 degrees. So that's what alpha is. Beta will be doing a similar thing with beta. But instead, so beta is going to be U and J. So let all right, so then we have cosine of beta equaling 2 to 1, I believe. Yep. 0, 1, 0. And we already know what these magnitudes are. This magnitude is 3, and the magnitude of J will be 1 again. So the magnitude of U doesn't change. So we did that earlier. All right, so we just really need the dot product here. And so the only thing that we have here is the 2, is we have 2, 0, 2 times 0, 2 times 1, and 1 times 1 times 0. So that's again 2/3. So that means that beta is 48 degrees as well. And finally, we want gamma. So we'll let gamma equal u times k. So cosine of gamma, that's going to be 1 in our numerator, and this is going to be 3. Same as before, the denominator is not going to change. And so gamma will equal the inverse cosine 1/3. Let's take care of that. Inverse cosine of 1 divided by 71, rounded to the nearest integer. And there you go. So alpha is 48 degrees. Beta is 48 degrees. And gamma is 71 degrees.